Hi guys. Okay, so I think my screen is visible now. So hi guys, welcome to another live coding session. So can you guys
Good
hear
afternoon,
me?
sir.
Yes, good
Yes, can you hear
afternoon.
me, sir?
Yes, I can hear you.
Okay.
So can you see my screen?
Yes, can see your screen.
Yeah, all right, no problem. Okay, so welcome to the last live coding session. And as I mentioned in the last coding session, we'll be deploying our apps today. We worked on two apps where the first app called the second app to get random values from the second app, and then we display these values on this on we just display the values using the first app. So we created two apps trying to imitate a front-end back-end kind of system. And then I mentioned that we were going to deploy the apps using Docker and then place them in a Kubernetes engine. So um, just to ensure that we try and cover as much as possible today, being the last live coding session, I had to do some work in the back end. So what will just be happening is rather than starting the coding from scratch, I'll just be doing like a brief walkthrough of some of the code. There will be some that will be done online, but majorly it will be like a brief, it will be like a walkthrough of things I've done before so that we'll be able to cover it in time, because coding from scratch might not give us enough time um, to do all we need to do. So I need to change what I'm sharing from. Yeah, let me just share my entire screen. Exactly. So now I'm sharing my entire screen. So yes, this was the first app, and the first app, I think this is the front end where we showed render templates. Where if you have to show HTML, we show you the simple HTML page, and if you show random, we show you the random number. And then in the back end, we just have two routes where when you call the generate number, we just generate a random digits between 0 and 1000, and then return that random digits. So now that we want to deploy, I just want us to take note of one change that we made. So previously, when we started the programming, when we programmed this last week, we had coded the URL part. So you can see this highlighted aspects. Let me try and increase my font a bit. So view, appearance, zoom in. Exactly. So this highlighted aspects, we okay. So we had coded this aspect because we knew that okay, whenever we ran the app, it was running on our local system at port 9000, and then we're getting generate number. But now, when you are moving from your local development and moving to environments that will be automated, environments where you will not be able to um go back to go and change things, you have to be able to pass in variables dynamically. So when we dynamically, anytime you type in something like this, these are called hard-coded variables. So variables where the values are coded in with text, we call these variables, we call them hard-coded variables, because these variables cannot change. Basically, they are hard coded in, and the only way you can change them is if you come into the code itself to change them in the code. And this requires that you have to stop your code and then restart your code before they change. But there's also another way that we can define variables, and this is the dynamic variable, and that is when your variables are not static. So this means based on things that are happening outside the main code itself, it's possible that the result that your variable is going to be having is different from what it was using previously. In some cases, you might need to restart your app for your dynamic variable to get loaded in. And in some cases, depending on how your app is working, you don't have to restart your app. Even as your app, as well, let's say it's something where you're using like a for loop or a while loop for that dynamic variable. So as long as your loop is running, where you have to re-access what the value of that dynamic variable is, you don't have to restart your app. As long as you have changed the dynamic variable where it is being fed into your program, that variable will also change automatically. So thinking of it in such a way, whenever we want to move deployment, we always have to ensure that the URL we are passing is not static, such as this. It has to be dynamic. And why do we do it this way? Because it's possible that you might be switching your deployment environment from one environment to another. It's possible that okay, you were hosting on Google Cloud platform before, and then you realize that okay, hosting on AWS might be cheaper. You now want to port from your GCP hosting to your you're porting from GCP hosting to AWS hosting. So if you had hard code the URL that was provided for you by your GCP deployment, that means when you move to AWS, you would have to stop whatever it is you are doing to ensure that you have to go and change the hard coded value that you had in your code. But when you have made it dynamic, you don't have to stop your code. All you just have to do is to pass it in, and there are different ways to pass in dynamic variable, but the most standard and the most popular way is to use something called environment variables. So environment variables are variables that are accessible from your laptop's environment. So when they're accessible from your laptop environment, then these variables are what you can pass into your code. Not only Python, any code at all. So they are called environment variables, and you can read up on them because they are very, very useful and they are existent in every system. So be it a Windows system, a Linux system, a Mac operating system, whatever it is, you have access to environment variables. So what I've done now is there are in Python too, there are many ways to have environment variable. One of the methods that we have is to use .env. So to use .env, you need to create something called .env, and in that .env, you can then pass in. So this one we use .env when we are working locally. So when we have configured our after we have configured our app to ensure that it is not now working with static URLs, it is working with a an environment variable. When we are testing locally, we need to create something called a .env, and one of the ways that Python provide for us to do this is with .env. So .env is if there's a Python module, you can see I've imported .env here, and the Python module is called .env. If I just come here to probably search for it, do Python, we should not be wasting too much time on this. You can see .env. So Python.env is a module that was created to allow people to work with environment variables in their file without having to add those environment variables to their local system, to their actual systems. So with this now, once you have an environment variable, you just need to create a .env, and you need to have the python.env installed. So you just load .env, you import .env, and then you use this code there to load all your .env variables. Then with that, you can now use OS, because OS is inbuilt for Python. os.getenv, the base URL, and what have you, to get all of those kinds of stuff. So that's .env on this aspect, and then requirement.txt. So I came here, I had to add the python.env to the requirement.txt. So now just to test this, if okay, let's come back here. So I think in one of them we have to cd to app1, okay, and then in this one let's cd app2. Okay, so our app2, we had enabled python main.py to work. Okay, let me list this. Okay, yeah, python app2.py, sorry. Let me bring this here. Exactly. So python app2.py. So if I run this, then our backend is already loading on this particular server. So if I come here to app1 and then do the normal flask app app1.py run, okay, and then I run this code. So our first app should open. But if I come here now and go to our web browser, okay, in our web browser, if I run this, hello, we are here, this is working. But if I go to the show random aspect and I press enter, we should get an error. Okay, so you can see that the error we are getting is that no schema. Basically, we are not providing the base URL, is not being provided because we have changed it in app one. We have changed it from this to get a base URL. So where are we getting our base URL? We're getting our base URL from the environment. So OS provides us with something called getenv that gets environment file. So in this our environment URL now, I need to create something called base, okay, underscore URL, and this thing basic underscore URL. Then I'll say this is equals to. Now I can come here and pick this particular the base URL, Control C. So if I come here and say and paste this here, Control S. So if I save this, because we did not use this using debug, I have to stop this. Control L, and now let me add the debug tag. So debug, and now let's run this. So if we run this and go back to our code, and if we refresh this show random page, no schema supply. Did you mean HTTMS blah blah blah? So this is invalid URL. So let me come here now and see what am I getting. Base underscore URL, base underscore URL, load.env. Okay, let me print base underscore URL to ensure that we are actually getting the correct value from our environment variable. Okay, so you can see that base underscore URL is printing out correctly. So that's the actual base underscore URL. So since that is correct, then I should not be getting an issue. Okay, let me refresh the page and then let me do the generate or show random, sorry. Show and enter. So this is just saying in schema, no schema provided. Did you mean did I not add a format? Oh, I see, that's the issue. So I've added something called format. So format ensures that I'm not using base URL, I'm replacing base URL with the value of base URL here. So if I save this now and then I come here and refresh this page, so hopefully, yeah, our app is working as expected. We are getting a random value. So now we have refactored for deployment. So now let us now go into deployment with Docker. So before you can use Kubernetes to host any application, you need to have a containerized version of the application. And to create containerized version of application, we need to use something called Docker. So to create a Docker container, you first need to create a Docker image. And then after you create a Docker image, you then create a Docker container based on the Docker image. So once you have a Docker image available, you can then use that Docker image to create a container in your Kubernetes engine, or even if you just want to deploy a Docker. But before we do that, I want you to see something called Docker Hub. Okay, so because Docker Hub is just like the way we have GitHub. So instead of GitHub is for code repositories. Docker Hub is for Docker images. That's basically what Docker Hub is for. So Docker Hub is a platform where different users can begin to add different images that they have created locally. So because it's possible that just like basically what we use GitHub for, that is what Docker Hub is used for. But instead of for pushing code or files, what we push on Docker Hub is Docker images that were created with our system. So just like the way we have different repositories in Docker Hub, you can see that's in GitHub, sorry, that's how we have different repositories um in our Docker Hub also. So to start in it, if I just say S, so every repository is the name of the image basically. So instead of having every repository contains where your code files are, so every repository here contains your Docker image. So if you know that when you are creating a Docker image, because to create a Docker image, you need to do something called Docker build, okay, and dots. But whenever you need to also give your Docker image a name, and that's what we are doing with this /c. So you can read up on Docker command, but to build a Docker image, you need to Docker image. So let me call this, let me say app1. There need to be a space here, app1, and let me call it front end. Okay, but one thing you need to know is that if you just create an app, if you create a Docker image and the Docker image you just name it this way without adding your username for your Docker Hub. So you can see that my Docker Hub, this is my username. If you don't add your username for your Docker Hub, you cannot push that image to Docker Hub. At least that is for the free version of Docker Hub. For the paid version, I think there are ways where you can add images to your private repository without having to add your name. But the standard, just like the way when you want to push your code to a GitHub repository, you cannot just push a code to GitHub like GitHub alone. Your GitHub, after you specify the GitHub URL, you also need to specify your username and then the repository in your username that you want to push your code to. So that's why when you are creating an image and you know that the image is going to be leaving your local system eventually, or you know that the image is something that is going to be moving from your local system to a deployment environment, when you are done with all of your testing, you have to ensure that the name of the repository on Docker Hub that you want to add the image to, you include it there, then you slash before you now add the actual name of the image. Another thing that you can also do is that after you specify the name of the image, we have something called tag. So just like the way in GitHub, every push, because you must have read, I think when we read the Git aspect, you must have read that Git um, is a versioning tool. So for every push you make to GitHub, there's a commit message, there's a commit reference, there's a push tag. So you can always refer to this particular commit, that at this particular commit, when you make this particular push, what were the versions of that file? So you can have, even though you keep pushing to your GitHub, if you check your history, you see a list of different commits that you have made that shows you the history of how you have been pushing all of your apps, all of your apps to your GitHub, all of your code, sorry, every changes you have made to every code and every file, it is logged in your commit history. So just that way, we also have something like that in Docker, where for every version of the image you are creating, you can add a tag for that version of the image that lets you know that, okay, in this particular version of the image, this is different from the previous version. So let's say I had created a version here before where I had not changed it to a base URL version. I was still using the inbuilt version. If I wanted to create another version where I have changed it, I'll just name it another tag. So I'll show you where the tag is, and then with this we can build an image. But before we build the image in the app one, okay, let's go into the Docker file. So to build an image, you need something called the Docker file. And then a Docker file is pretty much like you writing YAML, but instead of saving the file with .yaml, you just save the file as a Docker file. If you don't save your file as a Docker file, then when you are building the image, you have to specify the name of the file. Okay, you have to specify the name of the file that you want. But because we are saving this as a Docker file, so the standard with Docker is that when you save your file that you are using to Dockerize, if you are saving it as a Docker file, then when you just use dots, when you use dots, so yeah, there can be no dots. So what we are trying to say here is, instead of, if you had not used Docker file, you'd have used like dot/f to say that, okay, this is the name of the Docker file that I'm using. But because you are following the standard and you're using Docker file, you just have to do dots, and then Docker understands that you want it to check this particular folder, you're in the app one folder. So check this particular folder for a file called Docker file, and then use that to create the Docker image. So now explaining what all of these here are. For every Docker image, there has to be a form. There has to be a base image that you're pulling from. The easiest way to explain this, the easiest way to understand this, if you look at when you have a system, a laptop, for example. I don't know if anyone here has experience buying a new laptop, but if you have at any point in time bought a new laptop, you would understand that when you buy a new laptop, you can decide what operating system you want to put on the laptop. So even if your laptop is a system that came in with a default operating system of Windows, for example, you can decide that you want to replace your Windows operating system, you want to replace it with an Ubuntu operating system. Or if your laptop came with a default version of Windows 7, you can remove your Windows 7 version and place a Windows 10 version on it. So that's basically what the form is. So for every Docker image that we want to create newly, it has to inherit from a previous Docker image, because you cannot just be the one that starts creating everything from the scratch. You have to, like, you need to know that, okay, so most times when we are using form, most times what we have here are operating systems. If I come here now, for example, and try to do something like Ubuntu, you can see that it has It has shown me the different kind of Ubuntu's that it has. So this is Ubuntu. If I do something like Windows, you can see that these are the different Windows 10 base images that one can use. So this is like Windows 10, there's Windows 10 Docker, Windows Dev, Windows for Sun, different things that people. This one was this Dapuyo slash Windows now is someone called Dapuyo that pushed his own Windows database to Docker, and it became so popular because people found out that the Docker image is so good. Because what this guy did now was that he added, because when the previous, let's say this Windows 10 here is just the Windows 10 base, but because we are on a Docker environment and not an actual system, there are some things that will be having some issues. Let's say for example now on your Windows system, you can use, like, you have a GUI, you have graphical user interface for some apps, but because this GUI is not present in a Docker environment, you have to do some configuration before you can start using some apps. So for example, that Puyo guy, whatever his name was able to come up with a Windows Java base image that was so good that people, it became so popular that people started using it. It became the standard. That anytime somebody wants to create a Windows Docker image and they want to use Java on it, instead of using the original Windows, you come and use this Java base. So that's basically what it is. So the creators of Python too also came up with a Python also came up with a Python image that anyone that wants to create an app that is Python based. So if you want to create a Docker image that is Python based, that the main engine you are working with is a Python image, then you can use the Python image. And just like the way when we are creating our name, we have a version here. Every image you are going to be using has a version. So you can use version 3.9, you can use version 3.10, version 3.11, 3.8, whatever version you know that is compatible with whatever app you are working with. That is what you use. Then they also have something called Slim. They added something called Slim because they know how heavy Python can be, especially on things like this. So they have Slim Bookworm, Slim Bullseye, Slim Buster. So you can read all of this later. When you start working with Docker images with research, you know, okay, this is the standard based image that I want to work with. For someone that wants to create a Docker image for like an app that is built with Node.js or npm, you will not start your base image with Python. You can start your base image with Ubuntu. Or if you are someone that, apart from using just the programming language, you also need access to like some operating system based commands or some operating system tools, then you'll be using Ubuntu as your base image. So depending on how much control you want, it tells us how higher up you have to go in the level of base image. And you can also create your own Docker image and use it as a base image. But that's something that you can learn on your own or study from that day, because just like you are using other people's own, you can also specify that, okay, from whatever the name of your own base image is, and then work with that. So that's what form is. Then we need something called a working directory. So what a work directory means is that after the base image has been pulled, you need a directory that will be created for you, where you will know that this is where all your files are stored. So after the base image, because the base image will have a lot of different folders, a lot of different directories that you as a person don't might not even be able to understand where all of the files in the base image are, because it's only the person that created the base image that knows the location of these files, location of that file. But you're also someone that wants to create an image, and for every image you are creating, you are going to want to include your own new files into that particular image. So you need to specify that, okay, of every action that me I will be performing, every file I will be creating is going to be added to a particular folder, and that's what the word directory is. So once you set the word directory, every actions like add, copy, cmd, entry point, blah blah blah, it is run in this particular directory because it sets it as the working directory that you are currently in. For example, on my local system now, my working directory here currently is app1. In this particular shell, if I go to app2, my working directory, let me close this, Control L, sorry, Control C and Control L. So my working directory here is app2. In this current one, my working directory is app1. If I come here, my working directory is delcs, because any action I'm going to be performing is going to be happening in the app2 folder. Any action here is happening in the app1 folder. Any action here is happening in the delcs folder. So that's what this work directory does. It ensures that, okay, We are specifying that in this work directory, this is what we want. And then expose, just like we know that we have ports. I think, did I show this with Docker images? I don't know. It's conflicting in my head. But expose, you can see the definition. Define the network port that the container will listen on at one time. So when you expose the port, this is what allows your container to be accessible from outside. I think I explained this over the course of the live coding session. So that's what we expose. So you need to expose a port that you know that your app is working on. So because I know that I'm going to be running this app on port 7000, that is why I'm exposing port 7000. So if I run my app now and run my app on port 5000, for example, I'm now exposing port 7000. Nothing will be able to connect to this my app that I'm running, because the port exposed to the outer environment, because this port 7000 they are saying now is inner environment. Only apps in the same inner environment of the container can access it. So this expose means that okay, we want external apps or external bodies to be able to access this particular port. So if you're opening a port that is different from the port that your own app is also opening, then it is an issue because you will not be able to access your app. So copy, what this does is it just does a copy of your current source. It copies from source to destination. So our source is our local system, then our destination is the system, the location in the Docker image that we want to copy to. So when you use dot, most times dot refers to current folder. That's why in this now, when we use dot here, Docker understands that we are saying that in this current folder that we are in, we want to look for a Docker file. So most times in programming language terminology, when you use dots, you are referring to your current folder. So if I copy from dots, that means I'm copying from the current folder that I'm in on my local system, and I'm copying to dots, means I'm copying to the working directory that I've set in the image. So that's what this line here is doing. And then because as usual, I mentioned this that we need to run requirements. So in every creation, every Docker image you are creating, it's like a new image. So be it Python or Node.js or whatever environment, you need to install all of your requirements, all of the modules that are not native to Python that you are going to be using. You need to do them. And then we just use CMD. So CMD is the entry point. So it provides the default for executing a container. So the entry point must be specified. Then there can only be one CMD in a Docker file. So basically, what this does is that you are telling that okay, after you have performed all of this and the image has been created, anytime you want to use this image to create a container, you must run this particular code in that container. That's what this is just saying. So immediately the image has been created, for every time that you want to use any, be it on your local system, be it on AKS, be it on Kubernetes engine, as long as you are creating a container based on this image, I want you to run this particular command in that container. So that's what this is. So I'll save this and then I'll come and run this here. So you can see loading metadata, blah blah blah, pull token for Python. So it will do, so it will make some downloads that you need. So if we did not add the slim here, it will probably be larger, because I worked on a Python image some time ago, 3.9, and that one was up to around I think 150 MB or thereabouts, just for Python. So using Docker takes a lot of data most of the times, because just as I stated previously, when you are building a Docker image and something happens, that Docker image will not get created. So anything you have done beforehand just gets lost. So the only time your Docker image gets created is if every action you have run in this particular Docker image is running successfully. So you can see that from Python's name. So what the first part has been run successfully, it has pulled everything it needs to download for it to be able to run Python's name. Then it has created the working directory called code. So that's working directory called code. It doesn't need to show the expose aspects, but it is showing that it has copied everything, and now it is running the pip install. So you can see pip install is just installing everything that is in this requirement: Flask, request, python.m, blah blah blah. So all of these now, as long as any module that is required, so you can see it has downloaded all of the modules required to run the Python pip, and then it is exporting into a layer. So basically, this Python image has been created. So if I come here, if I go to this particular um if I go to this particular my Docker desktop now and I click on my images, you see that this image has been created, app one front end. Okay, the app one has been created, but there will still be an issue somewhere. I don't know if anyone has noticed. We don't really have much time. If not, I would have tried to ask someone what that issue is. But I'll just let you all know. So to create app 2, because I wanted to just split the Docker file for each app. That's why I split the apps into app 1 and app 2 different folders. It's also possible that everything can be on the same folder, and you just create a Docker file 1 and Docker file 2. It's just that when you want to run the Docker file for the second image, you are going to specify that okay, this Docker file is for this Docker file is for app 2. So I already know that this one is opening on port 7000. So now let's go into app 2. And in app 2, we know that we are opening on port 9000, okay? And then okay, that's majorly it. So the Docker file for app 2. So if we open this Docker file here for app 2, so we are using basically the same thing, Python 3.9 Slim, work directory code, expose 9000, and basically doing the same thing. But this time now we're not using the Docker, we're just using Python app 2, because in our app 2, we have shown that when you do if name is equals to main, you can do app.on. So I'll just come here and do the same thing. Okay, no, let me come here and pick up this code so that I won't have to write it again. So Docker build, Control C, and then I'll paste this here. It's just that now I'll be taking this to app 2, and instead of front end, it will be back end. Okay, and then this will also be v1. So if I run this, and the good thing about Docker is that if you are using something that is exactly the same as a previous Docker file, you can see that now we do not have to do all of those downloads again, because it has cached it. You can see this thing so called work directory code, it has cached it, this stuff. So when you are trying to, Docker itself automatically tries to create something called cache. So that cache ensures that when you are, so that's one of the ways that you save data, the data that Docker created. Because if you have to keep downloading everything again, you waste a lot of data. You waste a lot of data basically. So what Docker did is that for every command that has been successfully run, it creates a cache for it. So if you are creating a new Docker file, or if something happened when you were creating that Docker image and you have fixed it and you want to run it again, you will not have to start the operation from the beginning. But the reason why for us, we have to keep, you can see that when it was working, it downloaded all of the requirements again, was because I added this command there, no cache directory. So what no cache directory means is that I've told Docker, and I've told Docker from Python, because when this is a Python command, the pip install no cache directory tells the environment that for this particular requirements that you want to install, don't create a cache directory. While this might not look sensible, because what cache does is it helps us save data. The issue with cache is that it saves data, but it enlarges your space, because the cache directory is going to be stored in the Docker file itself, in the Docker image itself. So if, for example, you are installing requirements that are up to like 2 gig, and you're now creating a cache that is even not to the same 2 gig, that means your Docker image will go to 4 gig. So that's why when we are running requirements, even though it means that we have to spend a lot of data, we try and ensure that we don't create cache so that our app will not be too big. So now both our images have been created, the backend and the front end. So let us use this to create 2 different containers. So the first thing I'll be running is the backend container, and then let me just specify this called backend. Okay, and then I'll create a port to it on our local port. So let me also join 9000 to 9000 on our local port. So you can see, cannot import the name URL quotes from real plus blah blah blah, import URL quotes. So I think this is because of the Python version, Python 3.9. Let me try and images. Okay, in the front end also, if I run this, I should also get the same issue. Front end. Okay, let me bind 7000 to it, and we should also get the same issue. You cannot import. So that one is as a result of the Python version. So what I have to do is I have to go to the Docker version. Okay, let me delete this, and I have to go and change the version. But then I've always, okay, I think it's because it's slim. So let me use 3.9 only first, and then see what that gets us. Let me take it away from slim, because what slim does is it tries to create slim down packages. Or do I still have that error? Okay, I don't have it anymore. So let me app 2 backend. Okay, okay, I've made the mistake for that one, but let me show this for you. So this one now, let me name this another version. Let me name this version 2. So you see that if I name this one version 2 app 1, if this gets created successfully, you see it's because of like I stated previously, I created one of the stuff for 3.9. So it is not showing me that issue. Okay, so that's for the app 2. It has been done successfully. So if I come here now in my images, because I did not create a new version, because app 2 backend, I did not specify a new version. So what this does is it's created a new version, and then in the new version, the previous image became dangling. So you can see the previous image. The previous image here is dangling. So because you have used that name, the name that you have using for a previous image, you have used that same name for another image, and the previous image becomes dangling. And I also now want you to see the difference in size. See, when we were using Slim, just 139 MB, but now that we're using the regular Python version, our container size has gone to 1 gig, which is a lot. This is like almost a difference of around 800 MB in size, just for changing from the Slim version of Python to the main version of Python. So let us see if with the backend now, if this will go now that we're using the normal version instead of Slim. So 9,000. And then let me run this. Okay, this is taking some time. Okay, so this has run successfully. In the logs, so we are still seeing this particular issue. So let me just import error, and then let's go to something and see why we're having this error. So this probably, okay, is it that this environment Python 10 accept all cookies? So let me see. Was it this and doesn't specify this blah blah blah. So, oh, I see. So our Workezug version is different from the Flax version. So Flax 2.2.2 is not made for this version. So that's why we're having an issue. So let me come back here and see the Flax version that I'm using. Pip freeze. So this is why most times it is advisable to use pip freeze when you're creating your requirement.txt, because when you use prefreeze, you ensure that whatever version you are using is the version that is working locally. But because I'm not using virtual environment, if I do a prefreeze, I will have too many unneeded requirements in my requirement.txt. That's why I have to do it locally. So requirements, so I have to change this. Let me just come here and look for my Flask version, and that is the version I will specify. A B C D E F. Okay, I'm using 2.2.3. So what version of where's the book am I using? MNOPQIST exactly. So this also has to be 2.2.3. So let me come here and specify this for both of them. That's the first requirements.txt, and then in this requirements.txt also, let me specify this and save this. So instead of using the major one, let me use Slim, because we can see how great of a difference in size the Slim is from the previous one. So in this one, V1, instead of V1, the backend, I'll call it V2 because we did not create a V2 previously. So let this one, and then in the front end where I created the V2, I'll call that one V3. So let me create both of them now, and let's see if now that we have specified the version of that requirements, if that will not be an issue. So our time is this 4:46 already, and we're just deploying our containers. So while this is going on, is there probably any question that anyone wants to ask, so that I can just probably talk on it a bit before I continue? Any question? Anyone?
Hello, good
Okay, seems
afternoon.
yeah, good afternoon. I can hear you.
Yes, I have this issue with my system. It's
Okay.
saying that my system doesn't support virtualization. and I've tried
Virtualization.
to yes, and I've tried to um how will I put it? Access the settings from the BIOS while
Okay.
turning on the system.
Yeah.
I check all the
Virtualization. The
virtualization
setup
option
was
that is
enabled.
there. But after doing that, the PowerShell is still saying I still writing no for some part of the
No.
setting. I don't
Okay.
know what is going on.
I think what you need to do is on your system. I'm assuming that it is a Windows system. Come here. I
Yes,
hope you can see my screen.
yes, I
Um.
can see your screen.
Yeah. So search for this. Turn Windows features on or off on your system. So when you get this particular option, open it and
Okay,
then um let it come on. So you see a list of different features that are available for your system. So the default is that it's always turned off. So you can we have one here called Hyper-V. So you need to enable Hyper-V, but it's not really that important. So the virtual machine platform, okay. So one of these, I think based on the system. So what you can first do is enable this for containers. Okay.
okay,
Ensure that yours for containers is enabled. Then also ensure that your Hyper-V is also enabled. So if your Hyper-V is enabled, then the last thing you should check is the Windows subsystem for Linux. Okay, so you should enable those three. So if you ensure that those three are enabled, then one of them should be based on the version of the system, one of these you might not even see containers on your own. You get, but just try and ensure that when you come here, these things relating to virtualization. So I think you should also enable the hypervisor. So you can see that on this
okay,
hypervisor, you can see this pop-up. You can see that what the pop-up is saying is enables virtualization software to run on the Windows hypervisor. So this is another option. So depending on the version of the system, but
I
when you
can see
enable it,
containers. I can see containers
exactly,
here.
yeah. So enable that, enable
I've enabled
your
container Hyper-V.
exactly. So if you have both containers and Hyper-V, then try and just enable that, leave Hyper-V alone, because what happens is that Hyper-V clashes with the BSL sometimes. So that's why it has to be
Okay,
disabled. So try and enable containers, enable Hyper-V, and then press OK and restart your system. So you don't do that now, because doing that
of
will
course.
entail that you restart a system. So when you are done, so if after restarting your system you are still getting that issue, then go ahead to enable the Hyper-V, and then that should probably fix it.
All right. Thank you very
Yeah,
much.
yeah, no problem. So our images have been created for both of them. So now let us go back to Docker. So you can now see that now we have front end version 3, back end version 2, front end v2. So this is what I was telling you about tags. So all of these are not getting deleted. So with this, I can refer, okay, this was the issue I made in version 1 that made it not work. This issue I had in version 2, and all of those kind of stuff. So now I'll try and run the front end again. Now that I've specified this, and let me call this front end. I remember I said there's an issue, and the issue will still come up here. Um, okay, so let me run this. So hopefully, if we have sorted out our issue, no options such as debug. Hmm. Okay, so this is where the issue is coming from. So this issue is coming from the Flask one. So let me delete this for the front end. So debug. How? So I want to specify a port. Let me just try and get it locally before I then do it um on the app. Okay. So I want to start the app exactly. Then port 7,000. Okay, so I should get the same issue. Hmm. So you're saying, oh, I see. That's because 7,000 is taken already. So let me delete this container that is with 7,000. Okay. Now let me try to do this. App one dot by images. Okay, unused. Control L. But this is trying to work. I don't know why. I don't now know why. I think it's that's an error from the command line. So let me just try. Let me change this port here. I think that's an issue with app one port 7000. Okay. No codes, no such command help. Let me do flask help. Or let me no. I think what I need is flask run help actually. So I will know how to see. Okay, yeah. So this is the port. Exactly. So this should be correct. After you do run, you should also see a port. So I don't know why it is telling me that is wrong, because that should be the correct option for how to do it. So let me probably put debug. Okay. So that's port 7000. Then debug after. Blah blah blah. Okay. I think I know what is going on. So let me do this. And then okay. And let me place a comma and then do this. Let me save this now and then try to create the image again. So I'll still create this as v3. So this now, the only thing that is changing is the CMD, the internal. Exactly. So that should not take much of our time. Okay, so yeah, this has been created. So now let me go back and create and use that v3. So let me delete the dangling image and then try and ensure. Let me see if that has fixed it. This is taking much time than expected. So let me bind it on 7000 and front end. Okay. So now let me run this and see exactly. So this has worked successfully. So the main issue is that when you are using the CMD, for every command that should be separated by a space, instead of using space to separate it in the same tag, like in the between the same codes, instead of using a space to separate it, you have to separate each of them with a comma. I think that's how the CMD is built to run. So our front end is working successfully now. And because I bounded our local ports on 7000 to the 7000 of the container, if I click on this now, local 7000 is not working. Okay, let me try 127.168.0.1. Okay, this is still not working. Okay, serve mode is a deployment server running on HTTP. Okay, I see. So this is an issue with Flask again. So the issue with Flask is when you are using Flask to run an app, you have two options in an host, because when you are running the app with Flask with this kind of method, what happens is that Flask runs on your local system. So now that this is actually running on the local system, you can see that this is giving us the correct command, but we cannot access it even though our port was binded. Why is that? Because you can see that this is only running on HTTP 127, and the HTTP, this particular URL for the container, is different from that of our local system. So the only way you can do this is if you are inside the container and passing this URL inside the container. So if you want to ensure that we can access our Flask app from outside the container in this same particular thing, we have to make some edits here. So before passing the port, I need to also pass something called the host. Okay, so when you pass hosts, separate this with a comma, and then so the host now is going to be 4 zeros with a point. So what this does is that it tells Flask to know that it's possible where this computer, like the host computer where this Flask app is being run on, might not be the only place I want to access this app from. So ensure that this app is accessible anywhere, even if the URL is coming from outside the host computer. That's what this line of code that I've done here is doing. So if I now come here and we run this particular image, okay, if I run this particular image, I'll name this v4, and then let's run this. So this should fix our issue. For the other one, for app 2, we don't have to make that change in the command port. So for our app 2, it will be different. What I'll just have to come here now, I'll say host is equals to this way. I'll have the 4 zeros, 1 2 3 4, the last one, and then I'll specify the port. Okay, so you can see it says here port of the worker. If I come here to this back and see host, the host name to listen to, set this to 4 zeros to listen on any particular host. That's what this is showing us. So when you set this to 4 zeros to listen on any host, this ensures that your app will listen even if where you're accessing it from is not directly from the container that you're calling it from. So let me name this v3 and create this also. So if I come back here, so while our front end app from version 3 is still open, I'll go back to images, okay, and I'll create another front end app from version 4. So optional settings, oh, that's the issue. Okay, yeah, I'll use this to create something else. So let me call this front end underscore 2. And now you can see that because for the previous container, I'm using 7,000. If I try to use 7,000 here again, there will be an issue. But the way just to show you that the ports you're using in your container is not necessarily the same ports you're using in your app. So I will use for here, I'll use something called 5,000. And let me run this on port 5,000. So if I run this on port 5,000, so you can see now unexpected extra argument hosts. This is going to take much more time than I thought. But let me go to our backend and ensure that our backend is working as expected. Backend, okay, from v3. So let me run our backend from v3. Our backend from v3 is on port 9000. Okay, let me call this backend and I'll run this. So hopefully, so you can see now that it's running on all addresses, port 0.04 port, and then so now if I go to port 9000, you see that I can access the backend if I refresh this. And if I come here, localhost 9000, and do something called generate. I think we call it generate or something. I think generate random or generate number. That's let me just check that in the code. So in the app 2, so we go, okay, generate, though not an underscore, an hyphen. So generate number. So if I boot this now, you can see that we are generating the number, even though this is not running locally, this is running on our container. And if you go back to the container, you see that all of the printing and stuff that we specified, everything is in the container. So our backend is working as expected. Where we have an issue is the front end. So and that's because in the front end, when I created this particular Docker file for the front end, okay, so yeah, I should have double hyphens there called the host. So let me just confirm this again, so we won't have to create another Docker image. Okay, this is not the backend, I want the front end. Okay, Control L. So let me just go up a bit to this part exactly where we ran help. So you can see this is where we specify the host. So you need to specify the double hyphen before this host. So that was why we have an issue. So let me go back to the front end. I think we're having too many front end images. Let me delete this container. Okay, let me leave this one. Let me delete this front end too. Okay, our backend is running as expected. So in the images, our front end was v4. Let me delete it and create another v4 for front end. Okay, so now, yeah, another v4 for front end. So this should build successfully. And this is 5 p.m. already, and we have not even gone to the aspect of loading with Kubernetes. So what will happen is I'll try and rush through in another 10 to 15 minutes and just try and wrap up. So, sorry, is there
Hello.
another live coding session?
Yes, there's another.
Coding
Yes.
session. I see. All right, guys. So, what I'll do is, this is actually complete already. I mean, this file contains the Docker files and all of the deployment pods that is in there. So, what will happen is that since this last live coding session, I'll be creating a zip file Okay, I'll create a zip file that contains all of these codes and everything that is needed to complete it, and then I'll send you these codes. So I'll send it to the Slack channel where you guys can access it and then use that to play around and see if you have any issues while you're trying to get it up. Just ask the question on the channel and then we can sort it out. So thank you all for your time. It's actually not that fast trying to go through all of this coding. So but I do hope you guys can try and complete this at your leisure time, as this is the aspect of Docker. So let me just wrap this up and then I'll make sure I send the zip file to the Slack channel. Thank you all, and see you all in the next stage.
Thank
Bye.
you.